Good morning, Beta. Wait, I'm sharing the link in the group. Let's start the class, please. Good morning, Divya. Good morning, Paraja. Beta, today important questions we are going to study from complex numbers. Good morning, Rudra. Now look here, Beta. First, some important questions of multiplicative inverse concept you have already studied. Means what you have to do in multiplicative inverse. Okay. Now, today what we are going to do is we will solve some typical questions. Actually, they are not typical. You must know how to handle the question. Okay. So, question is if these are NCRT questions plus miscellaneous also. So A plus IB is given, A plus IB by C plus ID. A plus IB by C plus ID is equal to X plus IY. X plus IY. Then which one will be the correct option and how to solve this question? So after this question, there will be exactly four options given. Gagan, good morning, beta. So now look here, four options will be given. Based on that four options, you need to identify which one is the correct answer. So here, if it is given that a plus ib by c plus id is there, a plus ib by c plus id is equal to x plus iy. How to solve this question? Now what you need to do to prove that, either they will give you direct proof or they will give you option format. So what option is the correct option? A square plus b square by c square plus d square is equal to x square minus y square. Is this the correct option? Or option B, a square minus b square, c square minus d square is equal to x square plus y square. Option C, a square plus b square, c square plus d square is equal to x square plus y square. Or option D, a plus b by c square plus d square is equal to x square minus y square. So like this, four options will be given to you. In that four options, you need to identify which one is the correct answer. Understood? So like this, we have to solve the question. So what is the question given to you and what you have to prove? So among this, which one is the correct option? We don't know. Okay. Now first we will apply the strategy. So in this question, what strategy you have to apply? You need to check that one. Check, Nishika. So here, first what is given to you? A plus IB by C plus ID is equal to X plus IY. You do one thing, take it as equation 1. Okay, done. Now we will go for the next part. Now we will find conjugate of it. The best way is to find conjugate of it. So what we will do? We will do conjugate on both sides. So when you are applying conjugate on both sides, apply conjugate on both sides. So here also x plus iy, apply conjugate beta. So this will become your equation 2. Right now don't write equation 2. Conjugate means distribution of conjugate will be there. So here conjugate will be distributed in numerator and denominator both. So what we will do? A plus ib conjugate by c plus id conjugate. So when you are doing like this, equal to x plus iy conjugate. Now you have to exactly change. I hope everybody is listening me. So it will become a minus ib by c minus id is equal to x minus iy. This will become your equation 2. Once you got equation 1 and equation 2, what next work you have to do is you need to multiply equation 1 and 2. Listen to me carefully. Multiply equation 1 and 2. So write multiplying equation 1 and equation 2. So when you will multiply equation 1 and 2, what will happen? This one will multiply with this one. So a plus ib will multiply with a minus ib. Now denominator part c plus id will multiply with c minus id, and here x plus iy will multiply with x minus iy. Did you understood? A plus ib will multiply with a minus ib, c plus id will multiply with c minus id, x plus iy will multiply with x minus iy. So what is the strategy? First conjugate, multiply. Understood? Now multiply this one. It is coming in the format a is a x plus a plus b, a minus b. So what will it will become? It will become a square minus ib whole square, and denominator part c square minus id whole square. Similarly here x square minus iy whole square. So it will become a square minus I square b square, c square minus I square d square, and here also x square minus I square y square. Come on children, from here did you got the answer? Which option is going to be the correct one? Because if you check very carefully, a square plus minus ib square, I square value is what? Since we know I square is equal to minus 1. So once you are writing I square is equal to minus 1, what you are going to get? A square, I square value is minus 1. Minus into minus will become plus a square by b square, c square by c square plus d square is equal to x square plus y square. So this options is exactly, which option is exactly matching with the correct answer? Option number C. Because in A answer, x square minus y square was there. If you see cleverly, you check this one out. Here, x square minus y square was there. So this is 100% not the correct answer. The correct answer is C, that is a square plus b square by c square plus d square is equal to x square plus y square. So what strategy we adopted? One time again check this one. What strategy was needed is, here a plus ib by c plus I, what we have done? Conjugate. Only taking conjugate on both sides has solved the problem. Taking conjugate on both sides has solved the problem. I hope you might have understood this one. Come on, we'll go for the next question. Done this one? Come on, say children. If you have finished, you say okay, so that we will go for the next question. Come on, go for it. Then we will solve another question. Come on, go for it. Inform clearly. Done? Come on, say fast. Done or not? Quickly say. We'll go for the next one. Rudra, Payoja, Divya. Yes, Payoja has finished. Okay, very good. Super. Sujata, Gagan, finished? We'll go for next one, beta. So next question is, check this one out. Again, same pattern question is there. So what answer will come without solving? You see, question is a plus ib is equal to, solve, x plus I whole square by 2x square plus 1. Okay. Now here you need to prove. The question is, I'm giving you proof question. Prove that a square plus b square equal to x square plus 1y square by 2x square plus 1 whole square. Come on, go for it. How to solve this question? Go for it. Try this question out, please. You need to prove here. but here the question is little different also. X plus I, नोटबुक निकालो, पेन निकालो, सॉल्व करना शुरू करो, सोने का जरूरत नहीं है. Come on, start solving. Come here. Come on, try this question. A plus IB equal to x plus I whole square and 2x square by 2x square plus 1 is there. So when you are solving, how you are going to solve this question? Because you need to prove this one, a square plus b square by x square plus 1 whole square. This one you have to prove. Now how to solve this question? Come on, check this one out. So when they will give you this question, how to go with the question? First check this one out. So your given question is a plus ib is equal to x plus I whole square by 2x square plus 1. This is exactly your question. Okay. Now take this as equation 1. Again do conjugate of it. A plus IB. So applying conjugate on both sides. So x plus I whole square by 2x square plus 1. We will apply conjugate on both sides. Once you have applied conjugate, next work is this part is equation 1. Now conjugate part will be A minus IB. Here conjugate will be distributed. So here distribution of conjugate means beta x plus I whole square conjugate and 2x square plus 1 conjugate. Once you have applied this, it will become a minus ib is equal to x minus I whole square by 2x square plus 1, because real part is there, imaginary part is not there. If you see cleverly, here only real part is there. 2x square plus 1 conjugate means only real section is there. There is no imaginary section. So there will be no minus here, only plus will be there. Okay, because it is only considered as the real part, not the imaginary part. So now after this, what you are supposed to do is we will multiply this one with this one as per our rule, multiplying equation 1 and equation 2. So now multiplying, Divya, are you listening? Multiplying equation 1 with equation 2. Multiplying equation 1 with equation 2. So once you are multiplying equation 1 with equation 2, what you will get, a plus ib will multiply with a minus ib. Nishika, understanding? So a plus ib will be multiplying with a minus ib. A plus ib will be multiplied with a minus ib. Done. Now here x plus I whole square by 2x square plus 1 will be again multiplied with x minus I whole square by 2x square plus 1. Understood? Did you got it? So this part and this part will get multiplied. Now here a square minus ib whole square equal to, this is coming as x plus 1. So if you consider here, don't go for opening it. So it is a plus b, a minus b, again it is coming, and square format is there. So we will do x plus I, x minus I whole square distribution you do outside. And here this part will come directly, that is 2x square plus 1 whole square. So now this part will become a square plus b square. This section done, and here x plus I, x minus I. So x plus I, x minus I will become what beta? X square minus I square whole square by 2x square plus 1 whole square. So directly I square value is minus 1. So since we know I square value is minus 1, so what we will do, last step is needed. A square plus b square is equal to x square plus 1 whole square by 2x square plus 1 whole square. That's it. This is the end. That's it. This is the end, and we have to prove like this only. Okay. So no more big deals. Just you need to solve it. So what we did in 2 questions back to back, what I have taught is we have to apply conjugate and solve the question. Application of conjugate is a very simple process. We applied conjugate and we solved it. Multiplication section we have done and we have solved it. Is it okay? I'm calling you the name. Please kindly respond. Divya, understood? Payaja, understood? We'll go for another question if this is understandable for you. Miss, like this, whatever questions are given to you, I hope you will be able to solve this question. Yes, Rudra understood na beta? Okay, like this only one pattern question is there in NCRT. I hope you will be able to handle this question. Now beta, another question we are going to do. Last class I have talked about argon plane and argument. Polar form also I have discussed. Notes are available in your group. Okay. So now look here please. We'll go for the next question. Is it finished? Okay. Next question solve everyone. So find the least positive value of n. Find the least positive value of n. You have to find the least positive value of n. Okay. You need to find the least positive value of n if 1 plus I, remember this one, you have to exactly simple 1 minus I to the power n is equal to 1 given. So when this question is given, don't check it is what you call NCRT book, this question book, that question book. You just solve. Find the least positive value of n if 1 plus I to the power n by 1 minus I to the power, that is total, is exactly equal to n. It is given. Now you check what and all you can do so that you can get the least positive value. So options also they can be given, this question can be given in option format also. They will give you in option format A, B, C and D. In option format they may be giving you n is equal to 2, n is equal to 4, n is equal to 3 and n is equal to 1. So any four options will be given to you. Divya, still now you did not responded, beta. So any four options may be given to you. So once the four options are given to you, let's see which option you are going to. Come on, answer the question, please. Try this question out and answer the question. Come on, go for it, beta. Nishika, which one is the correct answer? One special class of trigonometry I will take, in that I will teach you real solutions. Sujata has given the answer B. Huh? B is the answer. Okay, Sujata Nishika has given the answer B. Let's check this one out now. So here it will become 1 plus I and 1 plus I. I rationalized it to the power n is equal to 1. So here this one will become 1 plus I whole square. But denominator part is coming as 1 square minus I square is equal to 1 to the power n. Okay, so rationalization has been done. After doing rationalization, what you need to do is, come on, check this one out. Option B, only one person has given answer. Rudra, what is the status? 1 plus I square plus 2I by 1 plus I, because I square will be minus 1. So minus of minus will become plus. Okay, so this to the power n is equal to 1 is there. So now 1 minus 1, because I square is minus 1, 1 minus 1 plus 2I by 2 is there. To the power n is equal to 1. So this is cancelled. So 2I by 2 to the power n is equal to 1. Cancel. So I to the power n is equal to 1. So when I to the power n will give you 1, see, I to the power n. When I to the power n will give you 1 beta, I to the power n will give you 1. So LHS is equal to RHS. In an equation, LHS is always equal to RHS. So what value of n will exactly, actually the question is least value. In the question, if you will see, find least positive. That means n has to be least, n has to be positive also. So here, when you will be checking, you must check one thing here, least positive. So I to the power n is equal to 1 given. So here, that means I square is giving you minus 1, I cube will give you minus I to the power 4 will give you 1. So here, I to the power 4 will give you 1. Since I to the power 4 is equal to 1, therefore n is equal to 4 is the least positive value. N is equal to 4 is the least positive value. I hope you might have understood. N is equal to 4 is the least positive value. This is exactly one of the most important thing. Now we will go for some typical questions to study. Very typical questions, and we need to be very, because here these questions are NCRT and NCRT exemplar questions, and we need to solve based on conjugate and modulus. So I'm solving one very important questions. It is exactly in NCRT, and yet it is a very typical question. Now this one is done, everyone. Come on, say yes if you have finished it. Come on, say yes beta if you have finished it, so that we'll go for the next question, please. Okay, if you have finished it, we will go for the next question. Now check this one out. Next question is, write the question very carefully. You itself try and solve the question. I will be explaining you what and all you have to do in this question. Okay, so if alpha and beta are different complex numbers, this question, if alpha and beta are different complex numbers, if alpha and beta are different complex numbers, alpha and beta are what beta, different complex numbers, and after that they have given that modulus of beta is equal to 1, modulus of beta they have given is 1, then we need to find the value of, find that beta minus alpha, 1 minus 1 minus alpha to the power bar, that is conjugate, into beta is equal to what? So this is your question, and you have to solve this question. Understood? So beta minus alpha, 1 minus alpha to the power bar beta, you have to find the value of this. Okay, so this will be what? So either they will give you this as question, or they will do one work, they will give you as options. So both we will do. Here answer is minus 1, 2, 4, 1. So these are the four options. Okay, these are the four options. Out of this, any four options, one answer is the correct answer. Come on, go for it, beta. So one technique, in this technique we are going to follow for this question, one important technique we are going to follow. Let's check this one out. Okay, when you are solving this question, the question is very clear to you. Now you have to adopt this question and solve this question. So now see here, one thing, if you see, modulus is exactly given. So we need to apply modulus and solve it. That should be the first concept. It should come in your brain. So now when modulus part is there, we will check the modulus section. Okay. So now let's see this one. Let's see this part. So what we are going to do is, we are going to adopt one formula. We know that modulus of z is equal to z into z conjugate. Modulus of z square. Okay. Modulus of z square is equal to z into z conjugate. This is the formula. We are going to use this format formula. Okay. So now start doing it. What is our z given? So this is exactly, we will consider it as z. Okay. If we will be considering this as z, then will it going to be our working part? Yes. What we will do, we will take it as beta minus alpha by 1 minus alpha to the power bar beta modulus whole square. Okay, till here done. Now equal to beta minus alpha by 1 minus alpha to the power bar beta into beta minus alpha, that is conjugate part we are going to write it, and here we will be putting conjugate. Till here it is done. Now once conjugate is given, you know that conjugate is distributive in nature. Conjugate will be distributed to every complex number. So we are going to distribute the conjugate part. So once we are distributing the conjugate part, this part don't touch. It will be beta minus alpha by 1 minus alpha bar beta whole square, and this part will be what beta? It will be beta minus alpha. Now they are both two different complex numbers, so it will be distributed. So beta distribution once you are doing, it will become beta bar minus alpha bar by here this part will be exactly first to distribute it. After distribution we will check the next part. So here it will become 1 minus alpha bar beta, and then here it will be distributed means 1 minus alpha. Here one critical thing is there, you must check this one out, bar to the power bar, because already one bar is given. When you are distributing, another bar will be given on it, and here it will become beta bar. That's it. So once you are exactly going to this level, after this you need to only start multiplication, okay? Because you must not forget that what is the question given to you to solve. So here it will become beta and beta bar will multiply, okay? So beta and beta bar will multiply, beta and alpha will multiply. So beta into alpha bar will come, and then minus alpha into beta bar, and then here minus alpha into alpha bar. So this is exactly given. We have just multiplied it, not a big deal we have done here. Denominator part, you check here it is 1 minus alpha bar beta, and here it is coming as 1 minus alpha beta bar. How this came? Because you remember one thing, we know that conjugate of conjugate is the same complex number. Conjugate of conjugate is the same complex number, based on that concept only. So now this time this part z into z bar, in the first formula itself you see b beta bar is there. That means b into conjugate of b. Once it will be written, we can write here modulus of b whole square directly using application 1, means the formula what we have exactly got. Based on that formula we have to solve. Now minus b alpha bar minus alpha beta bar minus modulus of this whole square came. Got it? So till here, good morning, Mohsin Sultan. Now look here, this is exactly the work beta. Now down you need to multiply it, means the denominator section. Now one by one we will start multiplication. But the real catch is only one step which will be very, very problematic to you. You need to be very careful beta for solving that step. Now look here, I am solving that step. Now check this one out beta. 1 will multiply with 1. Now beta alpha beta, so here it will become alpha beta bar minus alpha bar beta, and beta this 2 will multiply, minus into minus will become plus, and here what will be there, alpha into alpha bar. You please notice this section, alpha into alpha bar, beta into beta bar. For your understanding what I have done. Good morning, strawberry. Now look here, beta. Alpha into alpha bar, beta into beta bar. Till here we have done beta. Now in our question, if you will see, in our question part, they have given one thing, that is modulus of beta is equal to 1 given beta. So once modulus of beta is equal to 1, 11th na? Yeah, I know strawberry. That time you discussed with me na? Now look here beta. So alpha into alpha bar is modulus of alpha whole square is there. So we are going to just implement the part and write down beta, because whatever information has been given to us, now based on that information only we are going to solve it. Till here we have done it. Okay, now next section beta, because alpha square minus this part, if you check, minus into minus here, 1 plus will be there, plus will be there. Now here this part, this section came ne beta. Once this section is coming, alpha into alpha bar modulus of alpha whole square, this part. Now beta is exactly given, since our beta is given as 1. Done. So since beta is given as 1, what we will do, we will exactly make it as 1. 1. Done. Now next part is this section. Now in only in this section one small work is needed. I will be telling you what you have to do. This part you remember, just like minus alpha bar beta minus alpha beta bar, and this part will remain as it is. That is this much. Okay, numerator section is done. Till here everybody understood? Come on, see beta. Till here everybody understood? Now if you see here, you check alpha bar beta in denominator. Now see beta, minus alpha beta bar minus alpha bar beta minus alpha bar beta. This section will become what beta? This will become modulus of alpha square. This section will become modulus of beta square. So once you are writing modulus of alpha square, modulus of beta square, and since modulus of beta is actually what beta? It is 1. Actually we are in the verge of getting the answer. So by using this concept, now it is coming 1 minus alpha bar beta minus alpha beta bar and plus this section square. It is coming in numerator. Same, we are going to write denominator part is alpha bar square, this part, because this section will become 1. So once this section will become 1 means now it is similar to that of numerator. So minus alpha bar beta minus alpha beta bar plus same. So here this 2 will get cancelled. Once you are getting cancelling it, answer is coming as 1. So beta, once you are getting the answer as 1, your option is D. Your option is D. Then your option is D. What we have done in this question is, the moment we saw, I'm rewinding it. Now look here beta. The moment we saw this question, the question was this, and they asked that beta minus alpha bar beta, answer is coming as how much? So what we have done here is, first we used our mean formula, and that formula is modulus of whole square, modulus of a complex number whole square is equal to complex number multiplied to its conjugate. So now for that, instead of z, what I have done beta? Instead of z, I have exactly taken as beta minus alpha by 1 minus alpha conjugate into beta. This is the thing I have taken in our formula first. The moment I have taken that one, so this section went inside. Here instead of z, it is coming z into z bar is there. Okay. So once conjugate you have written, now conjugate part will be distributed. Conjugate will get distributed. After distribution, multiplication, simple method check. After distribution, multiplication beta. After multiplication, wherever only beta modulus is there, I have taken it as 1. Only that part, and answer is coming as 1 as the answer part. I hope you might have understood this one. We'll go for another question. Okay. This is again a proof question. This is NCERT exemplar question, competition wise or any other way if you will solve. It's a good question to solve. My question is, are you ready for the question, please children? Say fast, I'll explain the question. So question is, I'm starting the question beta. Question is, if conjugate of z1 is equal to conjugate of z2 is equal to, sorry, modulus I'm saying, I need to say modulus. So this is exactly coming till n, this will come till n. Unnati, how are you beta? So this is exactly coming modulus of z1 equal to modulus of z2 is equal to modulus of z3 till it is going modulus of zn. Okay. Now what you need to show here is, so I'm giving you the question, prove that prove that this is a proof question, children. Remember, I'm also okay, beta. How is your studies going on? So now look here, modulus of z1 plus z2 plus z3 till zn equal to 1 by, so now here also it will be in modulus only. Okay, so it will become 1 by z1 plus 1 by z2 plus 1 by z3 till it is coming as 1 by zn. Rudra, Payoja, did you understood what you have to do here, children? Come on, say. Nice, because of you. What I did, beta? I did nothing. Come on, go for it, beta. How to solve this question? Come on, check this one out. Unnati, try this question, beta. You're in 11th now. Now look at. So let's see how to solve this question. One small work we have to do, beta. Zn will be equal to 1. I missed one question. It will be equal to 1. Now, how to bring to denominator section? It's not a tough question. It's not at all a tough question. This is your question, beta. And you have to solve this question. Okay? This is the question and you need to solve this question. Question, okay, Rudra understood na, beta? Now look here, beta. How to solve this question? Payoja, Rudra, Sujata, Unnati, all of you are there. Strawberry. Now look here, beta. When you will be solving this question, one small technique you need to adopt. Okay, one small technique. After that, the work will be over. But I think first I should give you chance to solve it. But once you will apply this small technique, it will be done in no time. But the technique solving, putting is most important part. If you will be not doing it, answer will go here and there. Okay. Now look here, beta. First simple work is we will take LHS. In LHS section, one by one you start doing work. Okay. Here Z1 is there. What I will do, I will multiply Z1 with Z1 bar. So numerator and denominator, both part of first complex number, I multiplied conjugate of itself, means conjugate of Z1. Okay. Now Z2 is there. In that again I applied conjugate of it. Got it? Now Z3 is there. I have to apply conjugate of Z3. In the same way, we will proceed and it will become Zn conjugate by Zn conjugate. Now beta, here what I did is I applied conjugate of every complex number of itself. Okay, so its conjugate I multiplied up also and down also. Now let's check this one out, beta. So once we have applied conjugate, now what next work we need to do, beta? If you check it cleverly, you just see this one section. Okay, so now here Z into Z bar, again the same formula we are going to apply, beta. Z into Z bar is equal to modulus of Z whole square. Z into Z bar is equal to modulus of Z whole square. So Z into Z bar is there, beta. So what we will do, modulus of Z whole square by Z1 to the power bar is there. Okay, Z1 to the power bar is there. Will we be able to do any work? Check this one out. Modulus, just relax, don't think too much. Just do it. Z1 whole square, then Z2 modulus. Outside is modulus, conjugate part I did. Now look at Z3 modulus whole square by conjugate. That part we are going to write. Till Zn we are going to write, beta. So here done. See, this is the most important step we have done. So multiplying the complex conjugate in every consecutive one. I hope here I missed two. So now look here. After that, what we need to do here is, now we know that according to the question, Z1 modulus, Z2 modulus, Z3 modulus, everything is equal to 1. So we will write here 1. Now conjugate, I think we got success in bringing it down. We got success in bringing the complex number down. But this time our answer, here it is only one problem. Here you first write down. Since in the question it is given that Z1 modulus equal to Z2 modulus till Zn modulus value is 1. It is already given. Okay. So in the question it is given. So you need to tell them that it is given actually. It is given actually. Okay. Now the next work is, we know that conjugate is distributive, so we can take conjugate up. So overall conjugate we can take up. Z1 we will take conjugate up. Now 1 by Z2 we will take conjugate up, and like this 1 by Zn conjugate we will take up. Done. So once you have taken conjugate up beta, now it is again, we are going reverse. Conjugate is distributed to every complex number. Now every complex number will show conjugate finally. Now we can write conjugate finally on top because of the presence of conjugate in every consecutive number. So here it will become 1 by this plus 1 by Z2, 1 by Z3 till 1 by Zn, conjugate will go total up. Okay, now only one thing will save us beta. Here only one thing will save us, and that one thing is, check this one out beta. Now this is exactly the bar part of complex. I am just writing this one as like this, bar, so that conjugate bar, so that you will be able to analyze it. Now we will write only one thing. We know that modulus like this and this all are same. All are same. So here one very important thing is कि when you are writing modulus of z is equal to modulus of conjugate of z, and that will be equal to minus of z modulus. So all of them are equal beta. So here direct we can write this equal to 1 by z1 plus 1 by z2 plus 1 by z3 till 1 by zn. Okay. So this is the end of the question, because they told us to prove this only. Nishika, did you got it? What you did? Understood. So first Z1 complex, Z1, Z2 complex multiplication, that was our first duty. After that, converting it into modulus, second duty. In the question itself, they have given modulus part equal to 0, sorry, modulus part equal to 1. So 1, 1, 1 written. Now conjugate, we took up, conjugate we finally wrote like this, and because of this formula, we got this answer. So this is exactly the steps we proceeded to solve the question. I hope you might have understood here. Rudra, everybody, any doubt is there? Please kindly say beta. If you have any doubt, please kindly inform me. Ah? Now look here beta. When you will be writing like this, please pay attention. Z1 bar by Z2 bar. It can be written as Z1 by Z2 whole bar. Okay, so here 1 by Z1, 1 by this part, once it became 1 by Z1 bar, 1 by Z2 bar, 1 by Z3 bar. So here first thing is that this bar we can take up na. So once you have taken bar, then total it is, I'm just reversing it. So if like this bar is given also, you can distribute it now. So here we have taken the distribution part as overall up section, and then we have written in the whole section. Understood? Just reverse of this I went here. Got it? So this always, you are going from here to here. I went from here to here. Okay. So once I went from there to there, I am getting this part. I hope till here everybody understood this one. So let's go for the next question, beta. Now, next question is, come on, solve this one. Payoja, Sujata, Rudra. Is it done, beta? Unnati, is it done? If you have understood, we'll go for the next one, beta. Okay, super. Now, beta, we are going to solve this question. Okay, next question. Little bit trick is there in the next question. Let's check this one out, beta. Little bit trick is there. You need to solve for this equation. Solve for equation. Write down z. Write down z square. Wait 1 minute, beta. Z square equal to modulus of z. Will you be able to do it? Z square is equal to modulus of z. No idea. Only solve for this equation. Solve the equation. Solve this equation. Now, if they will give you like this, how you are going to proceed? Try. They only told solve the equation. Solve the equation. So when they told you solve the equation, actually it is not a simple question. It's a very complex question. Can I solve? Only one small cutie question will be given to you, solve the equation, and after that the entire pillar will collapse. Solve this equation means how you are going to solve this question, beta. Now look here, because once they will be giving you to solve the question, we need to analyze it very carefully and then we need to solve the question, beta. Now look here, for solving this question, what and all things we are needing here, just check. Only one word. Take z is equal to x plus iy. Very carefully handle this question, beta. Z is equal to x plus iy. So write, let z is equal to x plus iy. Once you have taken two values of z, okay, tell me the values, beta. Now look here, z is equal to x plus iy. The moment you will take, what it will become, beta? X plus iy whole square equal to x plus iy conjugate. Done. Now this section will become x square plus I square y square plus 2xyi is equal to x minus iy. Okay, so this section will become x square minus y square plus 2xyi is equal to x minus iy. Now, beta, this is your equation 2. Okay, we have taken this one as equation 1. So, equation 1 only you can take. This question itself I am taking as equation 1. So, this is coming as equation 2. Now, beta, whenever any questions like this is given, real part will be equated to real and imaginary part will be equated to imaginary. That's the only mantra you have to follow. Understood or not? Real will be equated to real and imaginary will be equated to imaginary. Don't forget this one. So real will be equated to real. So what we will write, x square minus y square equal to x, beta. Okay. Real will be equated to real and imaginary will be equated to imaginary. Xy 2xy equal to minus y, beta. Come on, go for it. So 2xy equal to y. So first work what we will do, we will shift it this side. It will come 2x plus, it will become 2xy plus y equal to 0. Now take y. Okay. Okay, now take y, what you are getting, 2x plus 1 equal to 0. So one time y is coming as 0, one time x is coming as minus 1 by 2. So 100% two cases came. Okay, so z is equal to 0 and z is equal to 1. Let's check this one, because 0 means real and complex part value will be coming like that only. Let's check, we'll solve it. Now look here, till here we got y is equal to 0 and x is equal to minus 1 by 2. It's not a simple question. Only one cutie question was given, z square is equal to conjugate of z. After that the entire pillar. Good morning, Rita. Good morning, beta. So now look here, y is equal to 0 Hi Rita. Now y is equal to 0 and x is equal to minus 1 by 2 बेटा. कौन सी क्लास में है बेटा? कहाँ से हो? So y is equal to 0. I'm going for online. Say what happened? You call message him. 7. Time is 7. Now y is equal to 0 is there. So once 0 is exactly there, we are going to substitute. So where we are going to substitute? Here we got two equations now beta. Equation 3 and equation 4. So from this, so anyone we are going to substitute. So let's substitute it in equation. Which one? Tell me. Where I am going to put? I am going to put this value of y in equation 1. Come on. So once you are substituting y value in equation 1, x square minus 0 equal to x. So what is the value of x you are getting? X square minus x is equal to 0. X is coming as x minus 1 equal to 0. So one time x is coming as 0 and one time x is coming as 1. Okay, so here z will have two complex number. In first part itself you will get, remember this. See, when you have taken, check this one out beta, when you have taken y is equal to 0, substituted y is equal to 0 in equation 1. Beta, you got two values of x. You got how many values of x? You got two values of x. Listen very carefully. So now, after that, once you got two values of x, beta, now you need to do only one work. You write the complex number here. So complex number will be written what beta? Z is equal to x is 0 when y is 0. So 0 plus I 0. This is first complex number. Now second complex number will be written as z is equal to x is 1, y is 0. So 1 plus I 0. This is two complex numbers you got. Okay. But this is not the end, because you have another value, and that another value is x is equal to minus 1 by 2. With y is equal to 0, you got two complex numbers. Okay. When you substituted y is equal to 0 in equation 2, sorry, in equation 3. Okay. In equation 3, when you substituted y is equal to 0, you got two complex number. Now it's the time for x. So now we are going to substitute the value for x beta. Once you are going to substitute there, what you are going to get? Come on, check this one out beta. X equal to, is it visible or not? Better we'll write with white color only. So here x is equal to minus 1 by 2. We'll substitute in equation 1. Sorry, again I am telling equation 1. Substituting x is equal to minus 1 by 2 in equation 3. In equation 3 beta. So once you are substituting it in equation 3, what next work we are going to do beta? So once we are substituting this in equation 3, it will come minus 1 by 2 whole square minus y square equal to minus 1 by 2 beta. Okay. Now check it very carefully how to solve it. It will come 1 by 4 minus y square equal to minus 1 by 2. Shift it beta. 1 by 4 plus 1 by 2 equal to y square. Now it will become 1 by 4 multiply 2 up and down. So what you are getting beta? Y square equal to 3 by, sorry, directly can I write 3 because here it will become 2 by 4 plus 1 by 4. That is 3 by 4. Okay. So y square you are getting how much beta? 3 by 4. So once you are getting y square as 3 by 4, final work only you need to do beta. And that final work is y square equal to 3 by 4. Take root on both sides. Modulus of y equal to root 3 by 4. Then y will be equal to plus minus root 3 by 2. Bingo, we got the answer beta. Here, what is exactly the conclusion section beta? If you check it nicely, check this part beta. Here now x is equal to minus 1 by 2. Y is coming for two values, plus minus root 3 by 2. So again another complex number we are going to get. This time what will be our complex number beta? Z is equal to minus 1 by 2 plus root 3 by 2i, and z is equal to minus 1 by 2 minus root 3 by 2i. So exactly how many complex numbers we got? Exactly with that same kuti question, we got four complex numbers. Check here. Again, another complex numbers we got is this can be result or this can be result. So actually solving for x means trouble for you. Now look here beta. The question was very simple. The question was this only. They told that solve z square is equal to conjugate of z. That was the only part. What we did beta, we just z is equal to x plus iy we wrote, and then z is equal to x plus yy we assumed, and then LHS and RHS we substituted z, and then by solving we got two equations: real part equal to real part, imaginary part equal to imaginary part. So real part equal to real part written, and imaginary part equal to imaginary part. With that we got two equations, equation 3 and equation 4, and we got the value. With equation 4 we got two values: one time y is equal to 0, one time x is equal to minus 1 by 2. And with that beta we got, first, with y is equal to 0, we got two complex number. Then we got x is equal to minus 1 by 2. Na? With x is equal to minus 1 by 2, we got two complex number. And the two complex number with this is this one and this one. With y is equal to 0, we got two complex number. So total, with y is equal to 0, two complex number; with x is equal to minus 1 by 2, two complex numbers. So total four complex numbers we are getting here. I hope you might have understood, Sujata. Everyone, please kindly say, did you understood this part, children? Please quickly inform me. So there's no space for one more question. Time is going. Better linear inequalities. Next class, I am going to provide linear inequality classes. So based on NCRT, we have done question, MCQs, case study, and questions. Today, I think that our team will be sending to you personally. They will send you. Okay. So that's it for today, beta. Bye, everyone. Have a nice day.